Hello everyone, for today's video, I'm going to discuss how number system, binary conversion, and binary computation works. But first, let's talk about number system. Number system is a way of writing numbers using digits. These are the four types of number system. Number 1, unitary system. Number 2, decimal system. Number 3, scientific and engineering notation. And number 4, rounding of values. So now, let's talk about unitary system. When we say unitary system, this system is simple but wastes writing time and space. It is also clumsy for handling any calculations except a simple tally. So, unitary system is most likely like this. And unitary system is not suitable for multiplying or dividing numbers because it's only capable on adding and subtracting numbers. So, that's all for unitary system. Now, let's talk about decimal system. Decimal system is based upon the 10 fingers of man. It's nothing more than a code where each distinct quantity is assigned as a symbol. So, these following numbers right here is called Arabic numerals. Also, there are two types of decimal system. One is decimal integer or expanded notation, and number 2 is decimal fraction. So what is decimal integer? Decimal integer can be expressed as the sum of its digits times the power of 10. For example, 5, 6, 7, 8. First, you're going to find the exponent. So you're going to find the exponent by using this technique. So you're going to start with 0 on top, 1, 2, and 3. So there you have it. You have the exponents of the number. So the next you're going to do is multiply these numbers to the base of 10. So 5 multiplied by 10. So the exponent is you're going to put it at the top. So raised to 3. So just repeat the process on the other numbers. So to check this, here's the trick. You're just going to count the number of exponent and you're going to add that to the number of 0. So 5 multiplied by 10. So raised to 3. So you're just going to add 3 zeros to the 10. So 1, 1, 2, and 3. Just repeat the process on other numbers. If the exponent is 0, automatically it will be 1 because any number multiplied by 0 is 1. So the next step is solve the problem and add all the results. And if the equivalent is the same as the problem, your answer is correct. Now, since we're done with decimal integer or expanding notation, let's talk about decimal fraction. Decimal fraction is a string of decimal digits together with an embedded decimal point. So, for example, is 1, 2, 3, 4, and 5.543. So, you're going to extract the exponent 0, 1, 2, 3, 4. If the numbers are whole numbers, the exponent will be positive. But if the number is decimal, the exponent will be negative. In solving decimal fraction, it's like solving decimal integer, but using division. Because if the number has a negative exponent, you're going to fraction it and divide it. After that, solve the problem like decimal integer. And don't forget the decimal point in your answer. After you solve it all, the answer will be the same as the given. So if the answer is the same as your given, your answer is correct. Now, let's talk about scientific and engineering notation. In scientific and engineering notation, you're going to assume that there's a decimal point sitting next to the first number of the given. Then, count how many times you move the decimal points to the right because that number will be your exponent. After you do that, you will come up with an answer of 9.25 multiplied by 10 raised to 9. Now, let's talk about rounding of values. There are two types of rounding of values. One is nearest hundreds for whole numbers and number 2 is nearest hundredths is for decimal numbers. For example, in rounding of values, if the number is below 5, the number still remain. But if the number is 5 and above, the number will add 1. For example, 12,345, since 2 is the nearest to hundreds, the 100 will still remain. So the answer is 345. Same process in rounding of decimal numbers, but you're going to move it to the right, while whole numbers, you're going to move it to the left. So since the number near the nearest 100 is below 5, the answer will stay remain and the answer will be 0.125. Now, let's move on in truncating or chopping. In chopping, you're just going to chop the number with the decimal point or remove the decimal numbers. So, the answer will be whole numbers and only whole numbers will be the answer. Now, let's talk about binary system. In binary system, there are two types of conversion, binary to decimal and decimal to binary. But first, let's talk about decimal to binary conversion. In decimal to binary conversion, you're going to use division and you're going to divide it by 2. For example, 239 divided by 2. Your answers will be quotient and remainder. So the quotient is the answer after you divide the number by 2 and the remainder is the remainder in the number that you divide. It's either 0 or 1. You're going to stop dividing the numbers if you reach 0 and 1. The remainders, that will be your answer or the binary. So you're going to write it from bottom to top. And also, don't forget that binary numbers are composed of just two numbers, 0 and 1. So the answer will be 11101111. Now, let's talk about binary to decimal conversion. So in binary to decimal conversion, we're going to use the answer in the decimal to binary conversion that we solved, which is 11101111. In solving binary to decimal conversion, it's like solving a expanded notation problem. When you got all the exponent needed, you're going to expand it. But expanding in binary to decimal conversion is different because you're not going to expand it by 10. So you're going to do is you're going to raise it. So 2 raised to 7 is 2 times 2 times 2 times 2 times 2 times 2. So the answer will be 128. So you're just going to repeat that process and solve for the answers. And once you solve, you're just going to add it all. So the numbers that has 0 for the equation will be not counted because it's 0. So you're just going to add it all. So the answer will be 239, which is the same as the problem in the first question. So that's all for binary and decimal conversion and decimal to binary conversion. Now, we're going to talk about binary computation. There are 4 types of binary computation. 1. Binary addition, binary subtraction, binary multiplication, and binary division. In different types of binary computation, there are different types of binary rules. So for binary addition rule, 0 plus 0 equals 0, 0 plus 1 equals 1, 1 plus 0 equals 1, and 1 plus 1 equals 0, carry 1. In solving it, you're just going to use the addition rule. So 1 plus 0 equals 1, 1 plus 1 equals 0, carry 1. So 1 plus 0 equals 1, and 1 plus 0 equals 1 again. So the answer will be 1. So 1 plus 0 equals 1, so bring down 0 and 1. So the answer will be 1, 0, 1, 1, 0, 1. So now we're done in binary addition. Let's go to binary subtraction. So there is also a rule in binary subtraction. That is 0 minus 0 equals 0, 1 minus 0 equals 1, 1 minus 1 equals 0, and 0 minus 1 equals 0. Borrow 1. For example, 110011 minus 1010. The answer will be 10001. Same goes to binary multiplication. It also has a rule. The rule is 0 times 0 equals 0, 1 times 0 equals 0, 0 times 1 equals 0, and 1 times 1 equals 1. In binary multiplication, we're also going to use the process that we use in binary addition. For example, 11111 times 110. So you're going to multiply that using the binary multiplication rule, and then after multiplying, we're now using the binary addition rule. After you solve it, the answer will be 101111010. Now, let's move on to our last topic, which is binary division. Binary division has its own rule. So 0 divided by 1 is equal to 0, and 1 divided by 1 equals 1. Example, 100 divided by 1100. Before you divide, make sure that you know the value of the binary number. The value of binary number 100 is 4. So 110 can divide into 100 because the value of 110 is 6. So the answer will be 1. Then bring down the other numbers. So also check the value. So the value is also 4. So we can divide it to 100. So the answer will be 11. So that's all for binary division.